now going to look at the transformations of absolute value functions. And when doing this, we're going to compare two different functions for the absolute value, and then we're going to look at how that graph transformed. There's lots of vocabulary here, so make sure we take really good notes on the vocabulary coming in. So let's recall that the vertex form of our absolute value equation is f of x equals a times the absolute value of x minus h plus k. We know that the vertex is h comma k, which is our x value and y value for the vertex. We also know that the axis of symmetry is where our function, our graph, is split in half symmetrically, and it's in an absolute value function, it's always going to take place where the vertex is, because that's where the graph completely shifts from a positive or negative slope to its opposite. So the axis of symmetry, we have learned in the previous lesson, is always going to be our h value in our absolute value vertical functions. So we're going to put that it is the h value, which is our x value in our vertex. Okay? Now let's look at how these values in here cause transformations. Well, since h represents where the vertex is along the x value, then h is going to translate or shift our function either left or right. Translate horizontally then. Our k value represents how our vertex moves vertically. So k is going to translate our graph vertically. So this is going to move it up or down. How does A affect our graph? Well, we know that A correlates to the steepness of our V's, of our two lines that form together at the vertex. So if this is the parent function and A equals 1, if we have anything where A is greater than 1, it's going to make our graph more narrow. And if it's making it more narrow, it is stretching away, farther away from the x-axis. This is called a stretch. So this stretches away from x-axis. Now, if A is larger than 0 but less than 1, so now we're thinking our fraction numbers, then it's going to compress because it's going to become wider and it's going to compress towards the x-axis. So it's going to compress towards x-axis. So when A is larger than 1, we get more narrow lines. And when X is less than 1, it is now compressing towards it and it makes it wider. So now that we understand how these parts of our absolute value function can change the way a function or a graph is sitting, we'll look at doing an example and see what it looks like compared to the parent function that's already here. So now what if we have g of x, remember that's just the function of g, it's the same thing as f of x, is -3 times the absolute value of x minus 4, and then minus 1. Let's first identify our vertex. This is still a minus, so we know our vertex for x is positive. So our vertex then is 4 and -1 right here. We can see already that it has shifted from the parent function over to the right 4 units and down 1 unit. Horizontal shift, vertical shift, x, y. Now let's look at how our a value is going to affect this. This is a -3. So we know that a negative is going to cause our graph to reflect. We're going to add that in a moment to our notes. It's going to reflect across the x-axis because now it's going to point down. It's -3, so I'm going down 3 over 1. And then I'll do the same on this side. So when a is less than 0, such as -3, it causes the graph to reflect over the x-axis.